But I really like this example here because this video only has one tiny 1 or 2 second clip with baseball, and the video API is able to find that for us. So we can jump to it right here, and we can see that this is from last year when the Cubs won the World Series. This is Google's year-end search video, which highlights top searches from throughout the year. So there's many different clips happening in this video. If I were to manually watch it, there's a chance I might miss that baseball clip. So we can see the video API was able to highlight that exact moment for us. So it used to take hours with the video API, now it takes just seconds or minutes. I'll do one more search. It's a little cold out right now, so it might be nice to go to a beach. And while machine learning can't take us there, it can do the next best thing and find us all of our beach videos. So if we search for beach, we can see here that it's identified all of the scenes in our videos that contain a beach, which is pretty cool. So that is a demo showing the Video Intelligence API. So let's take a look at the JSON response for scene level annotations in the Video API. We can see here that we have a clip in our video that contains a bird's eye view scene in it. And the Video API is able to identify this as a bird's eye view. And in that segment object, it's able to identify the start time and end time for this label in our video. It also gives us a confidence score of how confident it is that it was able to correctly identify this as bird's eye view. So we just saw 2 APIs that help us understand visual content, like images and video. Next, we're going to transition into the understanding section and take a look at some APIs that help us make sense of language. We'll start with Cloud Speech. Cloud Speech is an API that lets us perform speech-to-text transcription in over 100 languages. First, at its core, it lets us pass an audio file, and then it returns a text transcription of that file. A new feature that we recently added to the API is speech timestamps. And what this returns is a timestamp for each word in your audio file. This makes it really easy to search within your audio. So if you want to jump to a particular time when a specific word was spoken, you can do that really easily with speech timestamps. It also offers profanity filtering, and it supports batch and streaming transcription. If you want, you can send it a complete audio file. You can also send it a continuous stream of audio, and it'll continue to return transcriptions. The best way to see how the speech API works is through a demo. In this demo, I've extracted the audio from a couple of videos using FFmpeg. Then I sent the audio from all of those videos to Cloud Speech to get the transcription and timestamps. So this demo is going to highlight the timestamp feature specifically. Then I've created a UI to search within the audio for all of these videos. Let's take a look. So this is a video of Oars talking about GCP pricing. And what we see below the video is the speech API's transcription of the video. And what I've done here is made it so that you can jump to any specific point in the video using speech timestamps. So if I click here, we can see that the video jumps to that exact point. So I have a couple different videos here about different cloud or Firebase products. So let's say I want to search within my video transcripts. I want to search for all my videos that mention Firebase. So I'm going to do that here, and we can see that I get a list of the videos mentioning Firebase in the audio, and I can jump to the specific points where Firebase was mentioned in these videos, which is pretty cool. In the second video, we only have one mention of Firebase, but using the speech API, we're able to jump right to that point. I want to talk a little bit about how that demo is built. In addition to Cloud Speech, it also used Google Cloud Functions, Cloud Storage, and Google App Engine. In the back end, all of the video files are stored in Google Cloud Storage, and I have 2 Cloud Functions listening on that Cloud Storage bucket. Cloud Functions let you respond to different events in your cloud environment. So I have one Cloud Function that's triggered. Anytime video is added, it's going to extract the audio from that video using FFmpeg, and it's going to transcode that into a format that the Speech API can recognize. I have a separate function that's generating a thumbnail for my video UI. So once I have the audio extracted, I have a separate cloud storage bucket where I'm storing those audio files. And then I have another cloud function listening on that bucket to send all those audio files to Cloud Speech. And then they're being stored in a separate cloud storage bucket. So the front end doesn't call the Speech API directly. It accesses the videos from one cloud storage bucket and their associated transcription JSON from another cloud storage bucket. One company that's using Cloud Speech in production is Azar. Azar is a chat application that has connected over 15 billion people so far. They're using Cloud Speech anytime an audio message is sent between people. So whenever an audio message is sent, they use Cloud Speech to transcribe that message. And then for matches that don't speak the same language, they're also using Cloud Translation, which I'm going to talk about next, to translate that message into the other user's host language. One thing you might want to do with text once you've transcribed it is translate it. You likely have users all over the world, and you want to translate it into a language that makes it accessible for them. You can do that easily with cloud translation, which lets you translate text into over 100 languages. The features of cloud translation are pretty simple. You can either translate text, or you can simply detect the language of inputted text. Here's an example of calling cloud translation with Python. You just need to use the Google Cloud Python module, create a translate client, and then pass it the text you'd like to translate. Now notice here that I didn't need to tell it what language the original text is in. It's able to detect that automatically. I just need to tell it the source language which I'd like to translate the text to. Then I can grab the result and print it out. The last API I'm going to talk about today is Cloud Natural Language. Cloud Natural Language lets us understand text with a simple REST API request. Let's take a look at the features of Cloud Natural Language. You can use it to extract entities from text, detect sentiment, so you can see whether a given block of text is positive or negative. You can look closer into the linguistic details of text by analyzing syntax, and you can classify your text content into categories. The first feature I want to show you is analyzing syntax. And to do that, I have this example sentence. The Natural Language API helps us understand text. What I'm going to show you is a visualization of the JSON response we'll get back from the Natural Language API. The first thing it gives us is what we call a dependency parse tree. This tells us how different words in the sentence relate to each other. Then we get the parse label, which tells us the role of each word in the sentence. So for example, helps is the root verb, and API is the nominal subject. We also get the part of speech, so whether each word is a noun, a verb, or an adjective. And we get the lemma, which is the canonical form of the word. So for helps, the lemma is help. And this is really useful if you're counting how many times a specific word occurs in your text. You probably don't want to count helps and help as two separate things. You want to look for the lemma, or the canonical form of that word. And then finally, we get additional morphology details on each word in our sentence. And this is going to be different depending on which language you send to the Natural Language API. The next feature I want to look at is classifying content. So using this feature, you can pass text content to the API, and the content classification method will categorize this text for you into one of over 700 different categories. So in this example, I've taken the headline and the description from a news article, I've sent it to the API, and it's able to identify this as a baseball article with 99% confidence. And what's really cool about this is that it doesn't mention baseball anywhere in the article title or description, but it's able to extract this information for us. And you can see there's different levels of categories. So sports is the top tier category we get, then we get more specific with team sports, and then finally we get baseball. The next feature is entity extraction. And to show you how this works, I have a sentence about J.K. Rowling going along with the Harry Potter theme, and I wanted to see what entities it was able to extract from this sentence. So we got these 5 entities, and let's take a closer look at the JSON response for each of these entities. So notice that the first 3 are all mentions of J.K. Rowling. They're just different ways of referring to her. Robert Galbraith is a pen name she used for a different book series. So the API is able to normalize all of these to point to the same entity. So if we look at the details we get in the JSON response for her entity, we get her name, the type of entity is person, and then we get some additional metadata on this entity. So we get the MID, which is again, same as the Vision API. It's an ID that maps to this entity in Google's knowledge graph. And we get a Wikipedia URL for this entity. For British, the response looks similar. It also maps to the Wikipedia URL for United Kingdom. And for Harry Potter, the entity format looks similar as well. Now, if your entities don't have a Wikipedia page, the entity method will still return an entity for them, but it won't have any metadata associated with it. So if it mentioned my name in this sentence, I would still get an entity returned from the Natural Language API, but metadata would be empty because I don't have a Wikipedia page yet. The next feature of the API is analyzing sentiment. So for this example, the food was terrible, I will not go back. This is a review we might see for a restaurant. And if we worked at this restaurant, we'd probably want to flag this review, and we'd probably want to follow up with this person. But chances are we don't want to read all the reviews we're getting. Maybe we only want to respond to the most positive and most negative reviews. So with the sentiment analysis method, we can extract sentiment details on this piece of text. We get 2 values to help us do that. One is score, which ranges from -1 to 1 and tells us how negative or positive this text is. So for this one, we get -0.8, almost fully negative. And then magnitude tells us, regardless of being positive or negative, how strong is the sentiment in this text. And this is a value that ranges from 0 to infinity. This is normalized based on the length of the text, so we get a pretty small number here, 0.8, since this is just one sentence. The API also lets us do entity-based sentiment. So if we take this restaurant review, I liked the sushi, but the service was terrible. The aggregate sentiment for the whole sentence might not be so useful to us, but what we would want to know is that the person liked the sushi, but they didn't like the service. And the API is able to give us a sentiment value for each entity it finds. So here, for sushi, we get a sentiment score of 0.9, almost fully positive. And for service, we get a sentiment score of negative 0.9, almost fully negative. So we get some really useful insights here from entity-based sentiment. One industry we've seen these APIs used a lot is in customer service. So one example is, let's say you have a call center. You could use cloud speech to transcribe the audio from those calls. Then you might use cloud translation, if the calls are in different languages, to translate them all into the employee's host language. And finally, you could use cloud natural language to extract additional insights from those calls. So we've seen in the understanding section, we went through cloud speech, cloud translation, and cloud natural language. That's all I've got for today. I really encourage you to try out all of these APIs in the browser. If you go to any of the links for each of the APIs, you can upload your own images, video, audio, and text, and see the API response in the browser before you write any code. Then when you're ready to dive into code, you can take a look at the code from the demos in this talk in my personal GitHub repos, and we also have a number of client libraries to call the APIs from your favorite language. Thanks for tuning in.
Awesome. And next, joining us, we have our audiences from the AI track, where they just finished up a crash course on the machine learning APIs that we have at Google Cloud. Did you get a chance to watch that one?
So yeah, so not at this time. So I actually watched this one during the Australia-New Zealand session. So Sarah Robinson did this one. It's a really good introduction to the machine learning APIs. So if you don't have a bunch of data scientists on hand, and you don't have a bunch of PhDs in order to build those models, you can actually use some of the things that we've built for you. So a lot of pre-built solutions that you can just call the API, get the information that you need, and use those just by introducing those tools to your developer team.
That's correct. And what I particularly loved was about the video intelligence API, because that is really something unimaginable. Like if I were to watch a 1-minute video, I would probably be able to remember only about 50 things. But that's what the video intelligence API does. It completely maps out every single thing that you see throughout. So that's amazing. And I think the next session coming up in the AI track would be the reimagining conversational experience with the cloud speech and dialogue flow. That's really interesting, Jay. We've seen a lot of use cases and customers for that in India as well. So yeah. I think that should be one session to watch out for.
Yeah, chatbots in Southeast Asia, a very big topic. And if you're familiar with API.AI, it's been rebranded as Dialogflow. So you'll have a really good introduction there to Dialogflow and how it can be used to build those chatbots in a really sort of drag and drop kind of way.
Really interesting. And next, joining us are the industry solutions track audiences who've just finished attending a session on accelerating delivery of healthcare solutions with Google Cloud and AI. And the next on that same track is the future of financial services, cloud, and machine learning. So I think this is something really interesting, Jay. What do you say?
Yeah, I think for both healthcare, where they've just come out, and financial services, the most interesting there is both of these are heavily regulated industries. So the ability of those industries to leverage what Google Cloud can bring or what the cloud services can bring is extremely important. And those companies that can figure out how to leverage that the fastest and the best are going to be one step ahead of the competition. And in fact, there's a statistic that essentially 38% or companies across industries can expect an increase in profitability by 38% by introducing AI to their workflows.
Wow, that's some figure. So we'll let you guys go back to the sessions, go back to all the 3 tracks that we mentioned, and we'll see you once you're done.
Great.
Hi, everyone. Welcome back to Cloud OnAir, the journey from big data to AI. I'm Dan Aharon. I'm excited to be here with you guys, and I'm here to talk about human-computer interaction reimagined. We're going to focus sort of the first part of our talk today on conversational AI and dialogue flow, and then the second part of the session is going to be about speech recognition. Throughout the whole session, there are going to be expert Googlers available at your disposal. So if you have any questions, please go through the Q&A and ask whatever's on your mind, and we'll be here to help you. So let's start with conversational AI. So conversational AI is a really exciting space, and we're really just at the beginning of it. So you know, just a few chosen statistics, but there's way others out there. Analysts say 80% of all customer interactions that happen between businesses and customers today can be automated with chatbots or other conversational agents. So, you know, obviously that's huge. $65 billion of potential salary savings could be created by chatbots, and then, you know, obviously those efforts could be redeployed into other areas that would help those businesses. You know, if you look at the consumer side, they say they don't care as much about cost savings, but consumers will say, you know, 60% of them say that they actually want self-service. They're not always looking to talk to a human agent for every single thing that they want to do, especially if it's something simple and transactional. And then if you look at you know, what enterprises spend, chatbots and conversational AI is going to be bigger than mobile in a few years, which is, you know, obviously already pretty big. So that's quite exciting. There's a diverse set of use cases for conversational AI and chatbots, and we kind of touched a few of them in the previous slide. But the first big set is connecting businesses to their customers, and there you could think about you know, customer service or commerce through conversational channels. The second is controlling IoT devices, for example, operating your TV or operating your car with voice commands. And the third is connecting businesses to their employees, making information more readily available than it was up until now. However, as most of you know, the consensus out there is that most of these conversational agents are not that good, right? If you search on Google why chatbots, one of the first results is why chatbots fail. If you look on the right-hand side, you can see just one example of you know, a conversation gone bad, and this is pretty typical. There's you know, a lot of excitement and a lot of adoption for chatbots and conversational AI, but a lot of it is really not up to the consumer expectations. The good thing is we think with Dialogflow we can really address a bunch of these. So Dialogflow is making AI accessible. Dialogflow is built on conversational context. So you could get different answers depending on what users said previously in the conversation. And Dialogflow will allow you to integrate with your existing business systems and your existing systems for human live agents that will let you do escalation. Then for the other three, we're working very closely with customers to sort of help share best practices and help share guidance about how to build great conversational AI experiences, and we'll come back to that a little bit later in the presentation. So, you know, just at a high level about Dialogflow, what it does. So what it does is it takes unstructured text and turns it into structured text. So if you have this sentence where a user is asking for a pizza with different things on it, we turn it into a structure that then you can use in your business applications, like you can see on the bottom. What it doesn't do is, you know, it doesn't really understand your domain until you train it, and it doesn't do any of the fulfillment. Luckily, you know, we provide very easy tools to train, and GCP is a great place to host your fulfillment. So, you know, we're not going to, Dialogflow is not going to create the pizza for you, but GCP will help you connect to your backend systems that can do that. So Dialogflow is one of the most widely adopted conversational solutions out there today with over 300,000 developers. It's much larger than any other vendor that publishes their numbers, and we're very excited about the very terrific adoption that Dialogflow is seeing. When we hope you guys are going to help us sort of increase that community even further. So when we think about why people are choosing Dialogflow, we talk to developers and we ask them that question, and sort of the consistent answer that we get is people choose Dialogflow because it's a higher quality natural language solution, and the accuracy of the results is better. So they, even though all of these different solutions kind of look very similar, when you actually try and run them in production, what you find is, not everyone is able to give you that great end user experience and really understand what users are saying. And that's something that Dialogflow is, customers tell us Dialogflow is really, really good at. Beyond that, kind of if we go down into more details, there's kind of 3 areas that Dialogflow is differentiated on. It helps you build faster. You can really go to market in a few hours. You can build with some of our pre-built agents, or just start from scratch. You can engage very efficiently because it provides very advanced natural language tools, context, things like that can link together different intents. And you can maximize reach by going broad, having pretty large language coverage, creating multilingual agents, and going across all these platforms, which we'll come back to in a second. When we acquired API.AI, a lot of people were asking us, are you guys going to basically lock it down and make it only work with the Google ecosystem? In fact, the opposite of that is true. We're very excited about helping our developers create great end-user experiences for their users that go across all of these platforms. And we're only actually expanding our platform support over time. So that's something we're very excited about. Just a couple of the new announcements from the last month or two. Mid-November, we announced a new enterprise edition that's available in beta and is part of Google Cloud with all of the benefits that entails. We also announced speech recognition that is now available as part of Dialogflow built-in. Then in October, just prior to that, we announced a new built-in code editor that lets you actually build serverless functions from within Dialogflow, which is pretty exciting, and capabilities for multilingual agents. So instead of creating one agent for French and one for English, you can now create one agent that can handle both. So our new enterprise tier, this has been one of the top requests from customers. We've actually made Dialogflow free after the API.AI acquisition, and a lot of customers are super excited about the free tier. But we have some enterprise customers that told us they want something that's beyond the free tier, that gives them more production support, that gives them kind of more enterprise terms of service, that gives them SLA. And so we're proud to say that we now have the enterprise tier available in beta, and we'd love for all of you guys to try it and give us feedback about it. The other important thing about conversational AI is creating a simple experience and a simple bot can be done in a few hours, but creating really great experiences is hard. So for example, if you look at this image here, you can see 4 images. Each of them are objects from real life. You can see this broken rubber cover in the bottom left, or this metal cover on the bottom right. Whoever created them, didn't obviously intend for these to be perceived as faces, but when we look at them, we see faces and we perceive emotion. And that in the same way, your end users, when you create conversational experiences, are going to perceive emotion in those applications. And so creating a really great end user experience for these conversational applications requires investing in much more than just the coding or just building the NLU part. So we just outlined 7 steps of typically how people would build great applications, starting from identifying the top journeys through building a business plan, creating scripts. We're happy to help share best practices across all of these and help you guys create the best experiences. In terms of the kind of technology architecture, you can see on the left all of these different channels. So this could be text, could be from chat on the web or Facebook Messenger or Google Assistant on mobile. It could be digital voice from a mobile app, from a TV, from Google Home. Or it could be phone audio that's coming in through a gateway. Dialogflow helps you run conversations across all of these. And then understand what users want, understand their intent, and then it connects you to the backend fulfillment, which the easiest is to host it on Cloud Functions, but you can use any other Google Cloud services to host your fulfillment, or even host it on-prem if you'd like. And then you can connect it to all of your backend systems in the enterprise. So that's all that Dialogflow is today, and we're very, very proud and very excited about Dialogflow. The vision that we had when we acquired Dialogflow was that there's much more that we can do in this space. So this challenge of dealing with natural language has been a big challenge for Google across all of our products, starting from search through to Assistant, through to Gmail Smart Reply, translation, a bunch of other products. We've had to solve these challenges around natural language, and we've had to build a lot of these assets and capabilities that you see on the right-hand side. Over time, Dialogflow is going to benefit from all of these, and we're very excited about what we can deliver to developers like yourselves with Dialogflow, so you can create the best conversational experiences that builds on the best of Google. So with that, let me show you a quick demo, and then we'll transition to speech. Okay, so here, this is the Dialogflow screen, and I'm going to show you guys a demo that I created on stage at Google Cloud Next a few months ago. If you're interested in seeing how that was created, you can find that demo on YouTube. But now we don't have time to create it from scratch. I'm just going to show you how it works. So this is a chatbot or a conversational agent for an imaginary Google hardware store. So you can see there's an entity here for product, and there's Pixel, Home, Chromecast, Chromebook. Each one has a few different synonyms, and then you can see there's a few different entities. One entity is service. So things like, I'd like to fix my Chromebook is not working, can I please fix my Chromecast? You can see these are all examples of service, and in yellow you can see the product. And then the answer is, sure, no problem, dispatching service for product right away. Let's just clean that up a little bit. And then on the commerce side, you can see there's an intent for people that want to buy stuff. So we're requiring quantity, product, and address, and you can see there's a check mark next to these. So these are required parameters, and there's prompts if one of these is missing. So for example, if quantity is missing, it's going to ask how many we would like to buy. And then there's a text response here in the bottom. There's an output context here called shopping cart, which also connects to another intent called by another, and I'll show you that to you guys in a little bit. But one of the things I wanted to show you is with these one-click integrations, we can basically connect it anywhere we want. So you know, if we go to Facebook Messenger, for example, I can open up the Google Cloud Next test bot. And here I can say, my Pixel is not working. And you can see it's exactly the answer that we gave in the bot over there. If I look at the web demo, let's just click through and open it. Imagine this could be your website or your mobile app or wherever, and I can say, you know, I like to buy a few Google Homes. How many would you like to buy? Let's say 6. And then where would you like to ship it to? Let's try this by voice. New York, New York. And so you can see it's adding 6 Google Homes and sending to New York, New York, all in my shopping cart. Now, let me show you how that looks like on the developer side. So if I do the same thing here, and I say, you know, I'd like to buy Chromecast. Let's even say 5 Chromecasts. You can see it identifies that the intent is commerce. It identifies that it has a product, that it has a quantity, but it has no address. And so it's going to ask me for whatever's missing. Where would you like to ship it to? And now I can say 5 Fifth Street, New York, New York. And now notice how it created a shopping cart context. I can go to buy another, which is only activated with a shopping cart context. And let's say I say another one, please. What it did here is it added one more to my shopping cart. And now instead of 5, I have 6. If I do it again, you can see it'll say I have 7. So this is a 3-4 lines of code program that I wrote in Cloud Functions that's connected here with a webhook. And so we have this whole store conversational AI bot that was really created in roughly 15, 20 minutes on stage, plus those few lines of code. Pretty easy to do. And you can now deploy it in all these channels, and it works across everything that you'd like. If you go to these one-click integrations, you can connect it to any platform that you want. There's a few other things here that I'll just point out. We don't really have enough time to kind of go through them in detail, but we can make this a multilingual agent. So right now it's in English, but if we want, we can add a second language, and it will work in more than one language. There's a training tab here, so we can use some of the logs of conversations that have happened and tag things that we think it handled well or things that it didn't handle well, and add that to the training data that goes into the machine learning model. We can look at sort of some basic analytics integrated into Dialogflow, or use Chatbase that has more advanced analytics. And for fulfillment, we can either connect to a webhook, which is what I did, or if you look here in the bottom, there's actually a built-in code editor that you could use to build a full application right within Dialogflow. That's all we have time today for Dialogflow. But let's go back to the presentation and talk about speech. So Cloud Speech API is our commercial offering for speech recognition. It's available in over 110 languages. You know, it works in real-time streaming and in batch, and it works in noisy environments, and it offers phrase hints. But really, the interesting story about speech, it's you know, we built speech recognition internally at Google more than a decade ago, and it was never meant to be a commercial service. We kind of built it for our own internal purposes at Google. We've had to build it to work really well. And so it's built on a scale where it serves, you know, over 2 billion of our Android customers and hundreds of millions of iOS users. And the service is built to work in all of these different places that our users use it. So whether that's a person talking on a busy street in India with buses passing by, or another person asking their phone in Times Square in New York how to get to Union Square. It's really built to work in all those places. And now, starting from earlier this year that it was declared GA, we're now making this available to anyone through the cloud. So we're democratizing this technology, basically. So any startup, any enterprise, any student now has access to the same quality of speech recognition that Google's engineers do, which is very exciting. The technology has existed for a while, but what's interesting is now we're at an inflection point, because now it's actually much better than it ever was, and it opens up much more use cases that previously weren't available. So, there's two main sets of use cases. One which is around human-computer interaction, so things like mobile apps, web apps, IoT, phone-directed apps. All of these things speech can now be used for, because it's good, and it works really well with Dialogflow that you saw earlier, because you can now create voice-powered apps that work across all of these devices. You saw earlier in the demo how that could work. Another set of use cases is for speech analytics, where you want to look at human-to-human conversation and get some insights from that. So that could be call center analytics, it could be video analytics, it could be meetings analytics. There's three ways that you can use speech: streaming, the regular recognize, or long-running recognize. So we support all of them. Each one has its advantages. And we support a wide variety of standards, languages, and formats. Especially if you look on the left, it's pretty wide language support, and we're trying to make it easy to use, wherever you're coming from. Best practices for human-computer interaction is we recommend using streaming, because latency is really important for that use case. So it's worth the effort. Uncompressed audio or lossless compression is really preferred, and 16 kilohertz sampling rate or above for that use case. And phrase-ins really helps, because you have an idea of what the user might want to say. For speech analytics, we recommend using long-running recognize, because it's better suited for long files. Splitting speakers into channels is something that could really help. So if you're analyzing a phone call and there's two speakers, one on each channel, sending a stereo file that has both of those would be something that would be beneficial, versus creating a mono channel that has both of those speakers. That's a little bit harder to recognize. One other tool we have is DLP. So if you recognize speech that has PII in it, DLP can help you clean up that PII, and you should go. You should just look at our docs, learn more about it. It's a pretty cool product. So let me just show you a quick speech demo, so you have a sense of how speech works. So I'm throwing a big party this weekend, so I'm going to go to the supermarket, and I'm going to go buy some meat, and then I'm going to meet some friends. So I think that got 100% accuracy. It's not always 100% accurate, but when you use kind of high fidelity recording, it works really well. The other thing you guys may have noticed is that as I was talking, it was appearing on screen almost at the same time. It's really fast, which is really great for a lot of applications. The other thing you may have noticed is I was talking slow and fast in different sections of the utterance, and I was saying ums. It kind of cleans it up, and you can see really what the user intended to say. And last thing, I said the word meat twice, and you can see how it differentiates between meat and meat. The other cool thing is that it's really good at recognizing named entities. So to see that, I'm going to show you guys another demo, which is our it combines our speech recognition API with our natural language API. Our Cloud Natural Language API helps you identify sentiment and also recognize entities. So let's see how that looks like. I really like the Beatles. I love New York. And so you can see it identifies sentiment in these utterances. You can also see the speech recognition actually capitalized these terms because it knows they're named entities. And then the natural language API helped us identify them, extract the entity, and you can see these cards that are coming in from Wikipedia or from the knowledge graph. So that's a combination of speech API and natural language API. To learn more about Dialogflow, you can go to dialogflow.com or to cloud.google.com/dialogflow. To learn more about speech, go to cloud.google.com/speech. To learn more about natural language API, go to cloud.google.com/NL. Thank you for spending this time here with me. I hope you enjoyed it. Please don't go anywhere. If you have any questions, there's Googlers here to help you. Otherwise, just stay tuned, and there's a bunch more sessions here for Cloud on Air. We're looking forward to staying with you here. Thanks.
Hi, and welcome back. Hopefully you enjoyed that session from Dan talking about Dialogflow and how you can build chatbots easily.
Yes, and I agree. I think Dan spoke a lot about Dialogflow, which is our product which was called API.AI earlier, and now it has been set out for the enterprise version, which is called Dialogflow. So it's really interesting with all the use cases that he mentioned. And the next session we're going to have in the AI track is the machine learning at scale, which is about running TensorFlow in the cloud.
Yeah, definitely a really interesting session. And also coming back, who have just joined us, is the Industry Solutions track. So welcome back. So they just finished the Financial Services track, which is a really interesting track, and they're about to talk about retail customers in the next track for Industry Solutions. And then finally, our Big Data track just came back as well.
So I think the Big Data track just ended with simplifying ETL for Stream Analytics Solution. And it was an amazing session by Sergey. And now we're going to move ahead with the next track in Big Data, which is about fast tracking Apache Spark and Apache Hadoop with Google Cloud Data Proc. And I think this is going to be a really interesting session to watch out for. And what do you say, Jay?
Yeah, so I think with Spark and Hadoop and actually TensorFlow, we're really talking about a lot of the open source technologies that we have available that you can use on Google Cloud. A lot of these things you can run on premise on your own machines, and you can run on Google Cloud. And I think it's important for organizations to make sure that they can move their workloads between premises and clouds, and whenever they're using Google, hopefully it's because we're giving them the best price per performance, and we're taking away a lot of those headaches that they would normally experience when they manage their own clusters.
I agree. And I think it's all about open source at Google. And quickly, I think before all of you get started with your next tracks, I think a quick reminder of the queue button that we have on your left-hand side, which is to ask questions real time throughout the session, throughout any of the tracks that you're attending. And please select your track out of the 3, whichever one you want to attend.
Great.
We'll see you soon.
Welcome back to our global online conference, Cloud on Air, the journey from big data to AI. My name is Yufeng Guo, and today I'm going to be talking to you about machine learning at scale. Before we dive into things, I want to just make sure we're all on the same page about what is machine learning. For me, I've boiled it down to just a few words. Machine learning is using many examples to answer questions. We can take this definition and split it into its kind of two main parts, using many examples and answering questions. Those two correspond to training and prediction. These two parts are equally important, and they can be both done in the cloud or on your local machine or your local server. The training part, of course, is important and focused on a lot because it is what determines the quality of those answers. But I want to emphasize that the predicting or the answering of questions is equally important, because if you have the best model in the world, but you can't serve up your predictions to your users in a scalable manner, then what good is your model? So we'll take a look at both sides today, both the training and the prediction of machine learning. So stepping back, I want to just introduce, for those of you who are not familiar with it, TensorFlow. TensorFlow is Google's machine learning library, and it was open sourced in November of 2015. It's a fast and flexible library that is good for both research and prototyping, as well as being deployed to production. At its core, it is built on a distributed runtime and is made to scale. TensorFlow means the flowing of tensors. Tensors are just multi-dimensional arrays, and to flow them, it's just referring to having them flow through a graph of operations. So in this simple example of a graph, it's taking the 2 and the 3, and it flows through an addition operation to yield a 5. So at its core, these are the kinds of things you would see happening when running a TensorFlow program. But we'll operate at a much higher level of abstraction. TensorFlow supports many platforms. It supports the ones you would expect, like CPUs and GPUs, but it also runs on mobile and IoT. So for those of you who like to tinker or build apps, there's something here for you with TensorFlow as well. As I mentioned, TensorFlow runs on a distributed execution engine. And the front end of TensorFlow is wrapped with Python and a few other libraries and languages as well, but we'll focus on the Python option today. On top of this Python front end is a number of layers of more Python. First, we have the layers library, then the estimator library to help you build those models and run the evaluation loop for you. And what we'll focus on at the very top level are what we call canned estimators. They're models in a box, and they take care of just about everything, but still leave you the flexibility to configure the model to your liking. And so that's kind of the benefit here, is you trade off a little bit of customization while gaining a lot in terms of having a system that can be distributed and scale for you very nicely. So a quick example of what this looks like, let's focus in on the middle here, this is making a deep neural network classifier. And you can see that we only call a few options here to configure a model rather than building one from scratch. And for those of you who are familiar with machine learning and say, well, I want to configure everything, we got a lot of options for you to play with here as well. So it takes a while before you need to actually go down a level and build up a custom model truly from scratch. So that's enough code for the time being. Let's back up, and I want to tell you guys a little story. Let's say, a little thought experiment, we're going to make a new startup, right? We're going to make the hot new app, and it's going to predict what our users want to eat. Totally original idea, I know. And let's say you think about a use case, right? Someone says they want fried chicken, and maybe they get chicken and waffles. Okay. And so with that, you say, all right, I'm just going to launch and iterate. I'm going to do naive text matching and just say the user said fried chicken. I'm going to look it up in my menu and see which ones match with the words fried chicken. So you launch it, the user says fried chicken, and they get chicken fried rice. Not exactly what they were hoping for when they said fried chicken. So how can we fix this? Well, you see the feedback in your reviews on the App Store, and you'd say, it's OK. I'm going to reach into my machine learning toolbox and pull out linear regression. We're going to use basically fit, align, and memorize our users' preferences. So we train a linear TensorFlow model, deploy that, and your app starts getting traction. It's doing well. And the problem, though, is that now we're seeing a different kind of review. People are saying they're getting bored. Every time they ask for fried chicken, they get chicken and waffles. Every single time. And so your users are picky. Okay, that's understandable. And so you say, it's okay. I'm going to reach into my deep learning toolbox again and pull out deep neural networks. This will allow us to have generalized recommendations rather than memorizing the specific mapping from one request to its matching food item. One of the reasons why this works so well is that it leverages what are called embedding spaces. An embedding space is simply a way to represent our data so that they are kind of spatially more accurate, so that when things are farther apart, they're different, and things that are similar are more closer together. So say, for example, you have all of the fruits are clustered in one area of your space, and things like your grains are over here, your vegetables are closer together, and your desserts are somewhere else. And so this allows you to, when someone requests an item, like fried chicken, they will get something in that general vicinity. Maybe instead of chicken and waffles, they get chicken and pancakes or something. And so with this, your app starts doing quite well. It's doing well, but no good deed goes unpunished. You worked so hard, you implemented this deep neural network, but sometimes your users ask for a very specific thing. They're still picky. And so then they get something similar to that very specific thing, and they're not happy about that, right? For example, let's say the user asks for a iced decaf latte with non-fat milk, but they get a hot latte with whole milk. Not exactly right. So there are certain things that users really want you to give them what they want, give the people what they want, right? And certain things where they would just want general options, like when they ask for Italian food. So how do we